Alright, in this video we will be talking about Lewis structures. And specifically, I'm going to give you 5 easy steps to draw Lewis structures. If you do not follow these steps, it is highly unlikely, or let me say it is very easy to get the wrong structure. If you follow the steps, it's very difficult to get the wrong structure. In other words, if you follow the steps, you almost always do it right. So please just follow the steps. You start at 1, you go to 2, and I know this sounds kind of stupid, but every semester when I teach this, I give everybody these steps, and then they start at step 3 and they don't know why they got it wrong. So please just start at step 1. So Lewis structures, we talked about Lewis dot symbols or Lewis symbols. Lewis structures are using those dot symbols to create elements. I'm sorry, not elements, molecules. Okay, the dot structure or the dot symbols were simply for the elements by themselves. Now we're talking about molecules. So step number 1. First thing we need to do is we need to count the total number of valence electrons for the molecule. Okay, very, very simple. And we're going to do an example as we go. And that example is going to be CCl4. And if we count up all the valence electrons, remember, carbon has 4. We have 4 chlorines. Each chlorine has 7 electrons. So that works out to a total of 32 electrons. Simple. You don't do this first step, you get the structure wrong because you don't know when to stop. So please, again, just start with number 1 and then go on from there. All right, step 2. We're going to choose our central atom. Okay, and the central atom, it's pretty easy to pick. It's the one with the lowest electronegativity. And that is because it has to share the most electrons. Atoms with higher electronegativity don't like to share, they like to withdraw those electrons. And I'll give you a couple hints here. It is never, and I mean never, fluorine or hydrogen. Never fluorine or hydrogen. And I'll give you another hint. It's carbon if you have carbon. I'll just say it this way. Carbon likes to be in the middle. Okay. Carbon likes to be in the middle. So, I mean, this is not much of a step, but we'll put it down our central atom. There you go. Okay. Number 3. We place 1 bond to each terminal atom. And we want to bear in mind that 1 bond equals 2 electrons. 1 bond is the same as 2 electrons. And that'll make sense why that's important. So we already did the carbon. We already put that in the middle, so I'm going to make that black. And we want to put 1 bond to each chlorine. And we tend to just put them at right angles to each other, although this, as we'll learn in the next chapter, is not what this molecule looks like. Okay, so there is our, we call this the skeleton structure because we don't have all of the electrons placed. And at this point, it's a good idea to take that number of electrons, that 32 electrons, and just see how many we've used. So we had 32 electrons from above, and that's how many this molecule has, okay? We have 32 electrons to play with. It does not matter that carbon had 4 and chlorine had 7. We don't need to give them each their right number, okay? We're making a molecule, not elements. So the molecule has 32 electrons. It can only have 32. It cannot have 31, 33, or any other number. And we have to get them distributed correctly. So let's look and see how many we've used. We've used 2, 4, 6, 8 between the 4 bonds. Remember, each bond is 2 electrons. So 32 minus 8, that leaves us with 24 electrons to play with in the next step. Okay? Now step number 4. Place remaining electrons in pairs on terminal atoms to fill octets. Okay, place remaining electrons in pairs on terminal atoms to fill octets. So we have 24 electrons remaining, so let's go ahead and do that. I'm going to redraw that skeleton. You don't have to do it this way every time. I'm just doing it so you can see it being built as we go. Okay, so there's our skeleton. And now I'm just going to make a note here, 24 electrons. I'm going to place them in pairs around the chlorines. I have 4 chlorines, so that would be 6 electrons per chlorine. So let's put those in pairs, okay? And just to make things easier, I'm going to use this bigger pen. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and 24. Okay, so there it is. Now, step number 5. If all octets are full, then stop. Okay, and if not, share electrons to form multiple bonds. Okay, I'm not going to do that in this video. I'll save that for the next video. But let's look to make sure that all these octets are full. So what I'm going to do is I'm going to circle all the electrons for carbon. So inside that green circle we have 2, 4, 6, and 8. So carbon gets a smiley face. Okay, carbon's good. We don't need to worry about it. Now, let's do chlorine. So let's just do this chlorine. Doesn't matter which one we pick. Notice the bond is circled twice. Okay, the bond, those electrons are shared, so they count for the carbon, they count for the chlorine. Okay, so 2, 4, 6, 8, chlorine is good. And hopefully you can see that I don't need to do every single chlorine because they're all the same. Okay, so that Lewis structure is done. You don't need to do the circles with the highlighter, on an exam or something. But there's 2 things you need to ask yourself every time when you're done with a Lewis structure. Have I used all the electrons? And are all the octets full? Are all the octets full? If you answer yes to both these questions, then you are done. Just put your pencil down and walk away. Okay. Next time we'll do the if not in step 5.